started in computing, or what your interest might be. Sorry, guys, I'm just trying to see if, and this also goes for the folks that are in the online streaming room. If you guys want to introduce yourself, go ahead and raise your hand, and I will reach out to you in turn. Anyone want to say hello? Yep, okay, sure.
My name is Karandeep. This is my second meeting. I actually was here last month, but I showed up late, so I didn't do an intro. I got my start in computing when it was about 16 or 17. I took a Visual Basic class with a teacher that I really liked. And from there, I just started tinkering around with things. My undergraduate is actually not in CS. I did math and history, but after graduating, I've been in engineering, software engineering.
Very cool. Thank you. Anyone else want to say hello? Now, in an upcoming slide, we generally go to a, I guess, Red Robin, the chat. So you're going to meet us anyway. So you might as well introduce yourself.
Hi, my name is Tim Jones. I'm a senior software engineer at Nightingale College. I've been dabbling in Rust for like 3 or 4 years. I find it interesting, not what I use in my day job, but I'm here because I kind of like to dabble. So yeah, I got my start in computing, actually broke into tech about 5 years ago. My background's actually in biblical theology, so it's a really strange transition.
Wow.
But yeah, so yeah, love to meet you guys, connect. Thank you.
All right. Well, pleasure meeting you. I told you we had diverse people here, so that's great. That's great. Anyone else want to say hello? Let me check if anyone online has got their hand raised. No, we're all good. No one wants to make me run to the other end of the room? Yeah. Oh, we have a hand. Okay, yeah, go ahead and unmute Bob and can you introduce yourself?
This is Bob C. And you say there's a diversity of people here. Well, I'm an electrical engineer, and I'm always interested in learning new things. Done a lot of programming in my life, but I'm new to Rust, and so I'm sitting down with the books and reading.
Well, welcome. That's great to hear. I'm actually new to electrical engineering, so we're coming at it from opposite directions. That's great. Okay, thanks, Bob.
Okay.
All right. Okay, so we have upcoming, our meetings are typically the 3rd Thursday of every month. So our next meeting will be May 15th. Sounds early for a 3rd Thursday. I did double check. There are 5 Thursdays in May. So there you go. And then we're here on the June 19th and July 17th. The July 17th meeting, I don't know, have we confirmed that date, Lloyd? Or is it still tentative? Okay. I mean, we've got this, I think we've got this room reserved for the 17th, so. Okay. 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 So let me jump ahead. So we have Lloyd here. He's the head of the Northwest C++ Club. And hi, Lloyd. And if folks, we actually meet the same night. So the CPP guys are over there. Did we start a half hour before you? Is that what it is? You gotta. Okay, so the CPP group also meets here the same night. And we were talking, and Lloyd came up with this idea of having a language panel because there's a lot of innovation going on in the world of computing languages. And we also, know there's a lot of controversy and change happening. So it would be great to have a panel where people who have, either a lot of experience or even a little bit of experience with language can actually just sort of introduce it to a combined audience. And it'd be a great way to bring the two groups together. So our plan is to do that for the July meeting in this room. And so if we have anybody, are we still looking for speakers for those 4 languages, or have we found any? Okay. 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 So it's only Go? I mean, no, like nobody's heard of the other 3. That would be good. That would be awesome. That would be really good. That's right. I don't remember the name, but that one I do remember. Yeah. That's funny. Okay. Well, it's good to know. So if anyone here would like to speak to Go, can talk to me or talk to Lloyd, and we can show you sort of what we're planning to talk about and what you can do. It's important to call out. You don't have to be an expert in the language. Just if you've used it or you're curious enough to go and do the research to be able to talk about it on this template. We're trying to do a common introduction to all the different languages on the panel, so that way people get a sense of what some of the different languages have to offer. So you're welcome to do that. I will cross out the other 3 for the slides going forward. All right, so we've got volunteers. We've got a full boat of volunteers. So thank you, Benny. Where'd you go? Oh, there you are. Okay. For updating our meeting schedule on Discord. And Rory, I don't know if you're here tonight, Rory. Oh, there you are. Rory, thank you very much for maintaining the Discord, not the Discord, I should have said meetup, my apologies, for maintaining the meetup schedule. So going forward, when you get the invite via email, that's Rory maintaining that. So we also have Ben, and we have 2 other volunteers as well helping out. Hopefully, no one here is spending more than an hour a month on their duties. If you are, please talk to me. I don't want it to be a burden for everyone. But by splitting this up, it's really lightweight, hopefully for all of us, and this allows us to have a sustainable group that we can keep moving forward with. Okay. So anyway, thank you for the volunteers. A round of applause for them. I appreciate that. That's right. That's right. All right. So I think that covers all the slides. RustConf is coming to Seattle, September 2nd to 5th. I've working, I guess it was Sam, right? On the what's called the program committee for that. And we're part of the group of people that are picking through all of the submissions for talks. And they get anonymized, and we evaluate each of the submissions, and then we put them into a hat. We start to discuss them, and we end up with the submissions that go on to be at the conference. So we're on the program committee, and that work has begun. I've been asking questions about what other volunteers are needed. And the short answer is the other volunteer positions haven't been finalized yet. They've had their hands full just putting on the actual, like booking the venue and getting a few of those things working. But they are expecting to need about 10 to 30 volunteers. I have heard back that all of the volunteer positions will come with free admission to the conference, and that we will need help with people at the registration table. And at the very least, I've recently been asked by a different person on the Rust Foundation if I knew anybody interested in hosting a workshop. So I know you've hosted one before, Carl, at RustConf. Do you want to talk a little bit about what that entailed for you?
So last year at RustConf in Montreal, at the same time they put out the call for the 30-minute mainline talks, they also put out a proposal for workshops. They selected 3 of them. The 3 workshop facilitators arrived the day before, and our task was to present 3 hours of material to 25 people who had paid extra to come to our workshop. And for that, they gave us the same benefits that the other speakers got, although in my case, I did a lot more work because they wanted the workshops to be kind of like classes, and they wanted them to be hands-on. And because I didn't have a curriculum already established, I had my topics, but it took me a while to work all that out. And thanks to people in this group, I actually tested every hour of my workshop twice for volunteers in this
Nice.
group. So I don't know if that's what they mean
Yep.
by workshop.
It's going to be the same thing.
Okay.
It's
I was
either gonna be-
surprised they hadn't already put out the call at the same time
Well,
as the other talks.
Well, it's interesting because I didn't get any context either, and they asked me a cryptic question about workshops. And I'm like, what does this mean? You know, Anyway, they use some funny terminology. They're like, oh, do you want to run a workshop? So I said, do you know anybody who wants to run a workshop? So when I inquired about what that means, and it's also why I asked you a little bit about for some more details, because they weren't initially forthcoming with the details. I think it's because they're so busy,
Okay.
but it's either a half day or a full day. I believe they weren't 100% sure, but it's going to be 3 hours or more, right? It's a fair bit of work to prepare. People are paying probably $200 to go to your workshop. So hopefully you're bringing something of interest and substance to them. Ideally, it would be hands-on, right? Like you'd think of a workshop, and you're teaching some skills. It could be any level. There's no particular topic. I asked them, were there topics in the past that were particularly popular or particularly unpopular? And they said, that's a good question. I'll get back to you.
We
So-
all three workshops sold out in Montreal.
Yeah.
Mine was about porting code to the web and to embedded processors. And
Mhm.
the 25 people who signed up seemed
Yep.
happy to have that option.
Exactly. So it's really sort of something that you're passionate about, something that you're interested in. And if you have any interest in leading a workshop, then, come see me and we can chat a little bit more about it in detail. And if it looks like it's a good fit, I'll pass your name along to the foundation. Questions about that? Good hand.
Are volunteers needed for workshops, and are volunteers allowed to attend workshops?
Are volunteers needed for workshops? I think almost certainly volunteers will be needed for, like, one of the thoughts I had was, say, expanding one of the hands-on embedded systems talks that we've done in this class. And so for that, somebody on a Linux machine is going to have, a permissions issue talking to the USB port to get somebody else on a Windows machine is going to have. So having, say, 6 volunteers to cover the room while I'm teaching to the majority of people and a few people are having issues, that would be fantastic. But on another case, if you're dealing with something like a, more of a software-based workshop, you might not need that. So having helpers in the room is certainly a thing. As a volunteer, like if you're volunteering, say, for registration and you wanted to attend a workshop, I don't think the cost of that would necessarily be covered, but you should be able to have the freedom to go to one, right? If we have 10 to 30 volunteers, I can't imagine we would be in a situation where you couldn't help.
If you wanted to pay for a workshop and still volunteer, since it's the day before the main conference starts, I'm sure they could assign you to the registration desk some other
Yeah,
day.
yeah.
I had 2 helpers, but I think both were Rust Foundation staff people who
Sure.
had some time and were interested in the topics.
Right. So yeah, it seems like there's some flexibility here in terms of how you want to structure it, depending on what your needs are. But if you're asking about, can you have volunteers help you out? I think so. If you're asking as a volunteer, could you still attend? I think that's definitely true. Yes, you can do that. Does that answer your question? Yeah. Any other questions about RustConf? Okay. Oh, I should check the, I need like a second screen in case somebody raises their hand on the online. Okay, so that's great. All right, so I believe the one workshop that they wanted from the Seattle, they asked me about it is because they are looking for a community-based speaker, somebody from the local community. So that's what they are looking for. You're from the local community? I'm sorry? Okay, all right. Well, yeah, if you're interested, let me know. Okay.
3 or 4 workshops are currently locked down. So they're looking for the form.
Yeah. So I think this is one that's specifically held out for this local community. But if no one takes it, I'm sure they have other ones that they can do. And I thought about it, but I'm not going to do one. It's a lot of work and I do not have the time. So anyway, that's good. So other questions about the conference itself? I think it's at the Seattle Hyatt Regency. I was asked questions about where are there room rates? Do they have discounted rooms blocks at the hotel? They do not. And I was asked about whether the volunteer positions come with a free admission to the conference. Then yes, they do. Yes. So the question is, how many years has RustConf been going, and what is the turnout? That's a good question. I went to my first RustConf in 2020, and I don't know that that was the first one. Might have been. Does anybody know of an earlier RustConf? And yeah, 2017 was the first one. Okay, great. So sounds like 2017. So this will be, and I don't know if we stopped one for COVID, but this will be number 7 or 8. Attendance wise, it's pretty big, but I mean, it wasn't. I don't know if you've been to CPP Con or anything like that. It's not that big, but it's still a good size. It's still a good size. So many hundreds. What would you guys guess for Montreal? Well, how many attendees would you say there were there? Yeah. Yeah. Okay. Great. All right. So I think we're jumping around out of order. As always, we like to get together after and chat about all things Rust or all things technology. The Red Robin, we used to meet at a different venue, but we have some folks who are underage, so we want to make sure it's inclusive. So we moved to Red Robin, and it's been fantastic. The server there gets all the orders, and we generally close the place down, which is we were there a little too long last time. I felt bad for the servers. They were very patient. So I'm going to keep an eye on that tonight. But yes, we'll be there. We'll chat, and we'll connect over a bunch of things. As always, you can find a recording of this video on YouTube. Carl, thank you for being our editor/publisher for the YouTube videos. And as always, there's a call for speakers. Ben, if you want to stand up for a second, just so folks can see who you are. Ben is our speaker scheduler. So if you'll reach out to @bdillo, BDILLO, on Discord. If you don't remember that, you can ping me and I'll send you on to Ben. He can talk to you about, who your target audience is, how much time you need, and any scheduling constraints, and get you slotted in for whatever month you'd like to do your talk. So we've got all that set up for you. So tonight's talk, we have 2 lessons learned shipping Python, TypeScript, and Ruby libraries using Rust by Sam, and an intro to foreign function interfaces by Jack. All right. So I guess no problem. I've been jumping out of order. We can do it. We'll do Jack first. That's right.
Do I strap on a mic? Is that the easy way to do it?
Yeah, I think so. Knew I was going to trip over that.
Linux.
That's even more.
What are the odds?
Yeah,
Gambling.
Yeah, I know. We've come a long way.
that's right.
All right. Well, I guess it's just gonna. Yeah, great. It's mirroring. Perfect. Okay. Do that.
Yeah, and you could turn it on whenever you're
Okay.
ready to be heard.
Clicked in.
Yeah, watch out for this thing. It used to be here just to help you trip.
Okay.
And because it's taped down, that was the best I could do.
Great. My light is green. Does it sound like I'm amplified?
You can tap on the thing.
You're good. Okay. I can talk loud for the room, and I think this is for online. So Sam and I today are both going to talk about calling code in one language from code in another language. We're working on themes, see how the script goes. Raise your hand if you have ever written code in two different languages and had one of them call the other one in some way. So start shouting out which languages you used. Python and Rust. We're going to get some of that. What else? C and Rust. That's what I'm going to talk about. Any other examples people have done? Well, right. So over the network is sort of a different case. We're going to talk about within the process. But any other examples people have done? C++ and Rust. JavaScript and Rust. Scala and Java. That makes sense on the JVM. Yep. Python and Julia. I have no idea how that works, and I'd love to hear sometime.
Tangentially involved with Flutter and Rust.
Flutter and Rust. I'm not sure I even know what Flutter is, which is why I like coming to the meetup. So this happens all the time. There are all sorts of reasons to do it. For various historical reasons, it's often something and C. I think a lot of us have played with the sort of operating system details that make things kind of work that way. We're going to see some of that. In my heart of hearts, I want this to be a beginner-friendly talk, and I'm going to try. But calling one language from another language is inevitably a little bit complicated. I think those of us who've done it know what sort of build issues we run into, and just tricky stuff comes up, right? And for that reason, I think looking at how we call one language from another language is a great way to learn about how the languages actually work, right? Our computers and our programming languages are these big piles of complexity, and sometimes there's just an unlimited level of detail if you try to zoom in. And just looking at how these two big piles of complexity talk to each other, I think that's a great way to sort of get some intuition about how they work, because they have to agree on something, and that sort of forces some details out into the open. And even though foreign functions, right, calling functions in other languages is kind of an advanced topic, the funny thing is we do it all the time. And we do it even from like day one. Like the very first programming class you ever took, you probably printed something on day one. And it turns out that is going to be a foreign function call. And I want to walk through that. I want to kind of zoom in on that and just see that play out. I'm going to use go to definition a lot in my editor just to see what happens when we print something, and just zoom in on our first foreign function call that we all maybe made without knowing it. Before I dive in, raise your hand if you have never written even a single line of C. A couple people. I apologize, because we are going to be looking at C, and that is definitely going to, that's going to be a new thing, and a lot of things might make less sense. But hopefully the C will be doing simple enough things that we can kind of squint at it and not worry about the details. So I'll share the slides at some point over Discord. This is all just links, but what I'm going to actually do is jump into my editor. So this is one of the simplest programs we could possibly write. In Rust, those of us who have written some Rust know that we would probably start with println or something. That's the simple way to print things. Println is a macro, and it spits out a bunch of junk that I don't want to have to think about. So I've skipped one level of detail and just gone to standard output write. So this is the sort of standard write method on the standard libraries standard output type. Folks who are familiar with the IO traits might notice that write is a little bit slightly incorrect. It's probably more technically correct to use write all here. Sort of guarantees that all the characters got written out. There's going to be a lot of levels of detail. I have skipped that level. But this is the write method, the sort of most basic way you could write to anything, like a file, or in this case, standard out, whatever that might be. Let's see what's on the inside of that. So I have go to definition in my editor, and we are now in Rust standard library source code, which tends to be a little bit noisy, but we're just going to do our best here. So the write trait is implemented for the standard out type, okay, and we see that what write does is it calls write on a reference to itself. It's a little bit confusing, maybe a little bit surprising, but that's how they chose to do it. So if I go to definition there, Okay, that's a layer of complexity removed. Now we're on the implementation of the right trait for a reference to standard out. Fine. What does that do? It calls self.lock, and then it calls right on that. Okay, some of us may actually have seen that you can call lock. It's a public method in the standard library. You can lock standard output. It turns out that there are locks involved when we print things, and sometimes it's more efficient to take them ourselves. So this is actually a public method, lock. So it returns something. I'm not even going to ask what it is. I'm just going to go to definition on the right method. All right, so we are the right trait for standard out lock. There's a lifetime. Not talking about that at all today. Inner, borrow, mute, right. I don't know what that is, but I'm going to go to definition on the right method or whatever that is. And at this point, I kind of like that this happens because it's good for like we're doing this together experience. I've made a mistake actually here, or kind of I wound up going down a path I don't want to go down, because at this point I'm looking at whatever line writer is, and we can imagine, yeah, okay, when we print things, sometimes we buffer to the new line. Some of us may have seen that before, but the reason I don't want to be looking at these details is that here, this line writer, I don't know if I'm on camera if I lean, but this line writer is generic over some writer W. If you've seen the angle brackets before, right? This is generics in Rust. So this code is no longer specific to standard out. We've gone into some other tool. So if we keep going to definition, we're not gonna find the good stuff. So in this case, I have to back up. So I'm just gonna try something else. So in this case, let's just find out what inner is. You know, sometimes it's a little bit hard to figure out where to go, but in this case, I've tried this already before I started this talk, so I know that going to inner is going to help a little bit. Okay, so standard out lock contains a reentrant lock guard of a ref cell of a line writer of standard out raw. And that's a lot of crap, and we don't necessarily care about all this, right? We're just drilling in as fast as we can, and we're ignoring a lot of stuff on the sides. I think at this point, looking at this line, it's pretty clear. Oops, don't want to edit my standard library. It's pretty clear that we're going to want to go look at what standard out raw does. That's obviously where we're going to go with this. I cannot resist a tangent. So there's a ref cell inside of a lock. Isn't that weird? So a reentrant lock, some people know that buzzword, some people don't, is a lock that you can take more than once without deadlocking yourself. So it's like a mutex, but it lets you lock it twice. Why would we put a ref cell inside of a mutex? Anybody know? Raise your hand if you know. I cannot resist this tangent because this is so interesting. Right. So by sort of reentrant mutex's job is to let you lock it twice, as Ben said. And because it lets you lock it twice, the references that it gives you are not guaranteed to be unique. It can give you more than one. So it only gives you shared references to the object on the inside. So if you want to mutate it, you need another level of locking. But it can be single-threaded, so it's ref cell. This is a bunch of nonsense, but it's just, I love that detail. Let's go to definition on standard out raw. Okay, so standard out raw is a thin wrapper around something else called standard out. We're going to go to definition on that. I mean, we're just going to keep going. As I go through this step, I want to highlight that the file path where we are is in library, standard library, something, IO, something. So we're in the IO module of the standard library, which is familiar. We use that all the time. As I go to definition here, watch that file. So that just changed. So now we're no longer in the sort of portable IO module. Now we're in something called PAL Unix, which means, I think, platform abstraction layer. So now we're in like, this is no longer Windows code. This is just Unix code. Like we've sort of gone down a level of detail and we're looking at something called standard out, which contains nothing. Okay, I'm just gonna scroll down. Oh, read, okay, we're probably getting in the right direction. Right, great. What does write do? Some stuff, this time we're gonna totally skip the details. Manually drop, you can look it up in the docs. File descriptor, a bunch of Unix stuff. Who cares, who cares, who cares? Right, great, go to definition. Okay, something's going on. We're messing with error codes, but we're calling some function called libcwrite. Seems like we're getting somewhere interesting. I go to definition. Let me zoom out just a little bit. And now we are looking at a function that has no body. So who's looked in libc before or called functions from there? Smattering of hands. So this, if you have written C before, which many but not all of us have, this is kind of like a header file. Kind of. Like this is declaring a function that is implemented somewhere, but not here. And that function is called write. And it turns out that that function is implemented in the C standard library, which through compiler and linker magic gets included in all of our programs in some way, and we can call its functions. So that was a lot. This is links, and yeah, you can click on it later if you want to sort of follow this journey. But so like a lot of things are happening, and then at the bottom of it all, we're making a foreign function call into C code, which is going to do something in the operating system, but we don't care about that. So that's a lot of complexity. Can we do that ourselves, other than just like calling print? And the answer is yes. It's actually, we can strip away almost all of this detail, and I want to do it. My goal in this talk is to really just kind of throw stuff on the screen and give us the confidence that we could do it if we felt like it. So let's use a similar function. Write is not too complicated, but it takes a pointer and a length. I don't even want to think about it. Let's use a function called putchar. So I've thrown some code on the screen, and I think I have that same code in my terminal here. Right here, yes. And so if I open up a little window here and say cargo run, oh, that's not it. We can all agree that that does in fact print hello world. So what have I done? So this is very, very similar to what we were just looking at, right? So if I go, I'm going to go back to what we saw in libc, right? So we just saw pub function, but if I were to scroll up what looks like 1,000 lines, we might see the block that we see over here. So there's this extern C block, which is what's saying this is declaring a function that is not in Rust, or at least is not in this Rust. And it doesn't have a body, and we call it. We loop over the bytes of our string, and we just call it in a loop. So each call to putchar prints a byte, and we see hello world. If you ever like, I think the best evidence of the like tight integration between the C language and all of our operating systems is the fact that you can look for the documentation of the C functions in man pages. So I can say, for example, man putchar, and it will say, yep, here's the putchar function, and it takes an int and it returns an int. And if we go back to the code there, we see that I've called that C int, which is the type alias that we've imported from the standard library. But that's it. That's it, and it works. Any questions about that? Grab a sip of water while folks think about it. So this is calling a C function, and it's like 3 lines of code. Now, this is kind of cheating, right? It's not calling our C function. Right? It so happens because of compiler and linker magic, the C standard library is always available, and you can call all of its functions. But it would be a little bit more interesting if we could call our own C code, right? And that's not what's happening here. So the next example I want to jump to is calling our own code. And I'm going to put that on the screen, and it's going to be a little more complicated, and I'll try to keep it as tight as I can. Oh, excuse me. And of course, if you want to do this in the real world, you probably don't bother writing this declaration yourself because someone has already done that. That declaration is in the same libc crate that we were just looking at. You can just call this. Take libc as a dependency. So the simplest function I can think of is adding 1, but I needed 2 functions. So we're going to add 1 and then add 2. So this is the simplest example I could come up with of calling our own C code from our own Rust code. So then of course, because it's our own C code, we're going to have to compile it. As the folks who haven't written C may have written Java or C# or another Go compiled language, right? C is a compiled language. We have to invoke the compiler. We'll get to that, but we can look at the sort of just broad contours of what we're doing here. So where's the real code? There's a lot of code that's not real code, right? Like this unsafe extern C function has no body, right? And here in C, this declaration of add 1 has no body. So those aren't real code. But we see some real code. So okay, add 1 does actually add 1. That's Rust. It's got some junk around it. We'll talk about that. And over here in C, we have add 2, which I've implemented the obvious, most efficient way. And it does not have any junk, which is interesting. So I've used, instead of int, I've used int32t. I prefer that. I'm just sort of asserting how big the integer is. I could have used int. We saw the C int in the last example, but Other than that, just personal preference. There's nothing interesting about add2. It hasn't been annotated in any way. But the Rust function has been annotated with some special junk. I'll talk about that briefly. And mostly you just copy paste this instead of necessarily remembering how everything works. No mangle refers to, how to put this? You can have more than one function called foo, right? Because you can have a function in this module and a function in that module and a function in this crate and a function in that crate. And in C++, you can have overloaded functions, right? And so typically, because every function needs to have a unique name at the end of the day, the compiler just like invents some random numbers and gives them a unique name or something like that. And this is saying don't do that, because when C calls functions, it does not invent random numbers. It just expects them to have exactly that name in the binary. So this no mangle is saying do things the C way, use exactly this name. Yeah.
If you have two one.rs, you'll be able to do unsafe no mangle.
So the question is, if you have unsafe no mangle of function foo in two different files, what happens? I'm pretty certain the answer is that's a linker error. If not a compiler error, probably a linker error. Yeah, it'll say you have like multiple definitions of a symbol, I believe. We could try that, but live coding is dangerous, and so I'm gonna. Question. Yes, the question is, am I demonstrating both directions of calling? I repeat questions for the online folks. And the answer is yes. So if I go to, in my actual terminal, what I'm going to do, I think I have it right here. Yeah, you can see I've added a little bit of code that wasn't on the slide. I've added a test. So this test is going to serve as our main function. Test is going to call add2, which is the C function. So we're going from Rust into C. And add2, pull that file up. This is the code that was on the slide. Calls add1, which is the Rust function. It actually calls it twice. So yeah, so we're going to go from Rust to C and back into Rust, 2 of the second thing. Yeah, and just because there's no reason to hold everybody in suspense, I should be able to just say cargo test, and that passes, and we can we can convince ourselves like, oh, okay, let me go in here and say if I just screw it up and add an incorrect value, do my tests fail? Yes, they do. Okay, cool. So like this is actually running the code. That's nice. Unbreak it. And any other questions at this point? Because we're about to start talking about build.rs. There's not too much to say. I'm not going to say much about build.rs. So build.rs is Rust code that you write, and you write a main function in there, and whenever your crate is built, it runs. And it can do literally anything, which is kind of scary, and sometimes people make questionable decisions with what it does. But often what we need it to do is compile some C code for us, right? Because cargo does not directly compile C code. We have to do it, but there is this very, very convenient crate called CC. And if you're going to memorize any one thing from this little talk here, memorize that. CC. It's amazing. And you give it your file and you say compile. And in this case, it takes a name, but this name doesn't matter. This could be random stuff. The linker will ultimately see that name, but we don't care. And it just does all the right stuff. I've included the second line partly because it's a good idea to include it, and partly because it's a good example of like, how does build.rs actually work? So it's real code. It can do whatever it wants. So when we use CC, it's going to use the like standard process command utility to invoke the C compiler. It's going to compile our code. That's half of what it does. But then the other half of what it does is it needs to tell cargo to link that code. And again, those of us who have not written C, I apologize for using words that make no sense and have questionable historical etymology. But we need to link the .o file. I think technically it's a .a file. It doesn't matter, right? And we don't have to know it. We don't have to see it, but we do have to link that. And it turns out that the communication from build.rs back to cargo, there's great documentation on this. You can Google it and find the cargo docs for this, is all done with print statements. And they all look like this. They start with cargo : and there's a million of them, and they can do different things. This one is telling cargo, oh, by the way, if this file ever changes, I need you to rerun me. Because of course, if libc changes, yeah, we should probably recompile it. It would have been nice if CC did that automatically. On the other hand, because of the way header files work in C, it's tricky to do that automatically, especially in a cross-platform way. So I think they kind of gave up on it and said, if you care about this, do it yourself. But I include that mainly because it's nice to see it. Like this is ultimately what build.rs will do to talk to cargo, print statements like this. CC does a bunch. And if we had unlimited time, I would run it with like verbose flags, and we would see all the print statements that the CC build was emitting. It emits a bunch. Any questions about this? In the back. Yes, the question is what compiler optimization level or -O flags are going to be passed to CC in this case. I'm pretty sure, or passed to GCC, whatever compiler is being invoked. This works on Windows, by the way, which is incredible. The CC crate is one of the best things in Rust. I prefer, it's like better than make. Sorry, that's controversial. I believe the default behavior of CC build is to mirror whatever Rust optimization level you're using. So if you build in with -- release in Rust, which is the optimized build, it's probably going to pass -03 or some platform's appropriate thing. I'm sure they have a method that would let you override that. This sort of nice fluent method call thing. There's like 100 different methods you can call. Yeah, and when you start reading code in CC and you see some of the hacks they had to do to get it to work everywhere, it's impressive. Any other questions? Yeah.
For the recording purposes, it makes sense probably to point not with the hand but with the mouse cursor.
Yes, I should be pointing with my mouse cursor instead of my hand to highlight stuff. I know I'm on camera to some degree, but I don't see. Oh, they can see it. Oh no, look at that.
Yeah, you're good.
Sweet.
Can't they see the station share?
I think they can see this whole monitor.
Yeah, what we see and what you'll see in the recording are slightly different, but that entire screen is covered by the camera.
I get to cheat.
Live CC had to go with bindgen.
Well, okay, so the question is bindgen ? And the answer is next slide. I did, okay, I went ahead and threw this on the slide. So if we touch is a Unix command that says like update the modified time of this file, even though we're not really going to modify it, run that. It's going to force a rebuild. And then this little flag, I had to Google for that. I certainly don't remember it. But CC's documentation says set that environment variable if you want to see everything. I don't remember exactly why. So we should be able to run that. And right, it just prints an enormous amount of stuff. And if I had dependencies, it would be even more. But you can see it's setting. I think it's printing the environment variables that it's setting, or maybe the ones that it's I think it's printing the environment variables that it's reading. It's a little bit too much. This is I wanted to show this, right? So this is showing like, hey, I ran this command. And in this case, you can see we're compiling detect compiler family.c. That's not my code. You can imagine the sort of hacks they have to do to figure out what's actually going to work. But if I scroll down, eventually somewhere I find my stuff. Is this it? Have I found it? Lib. Yes, that's right. That is what I called my file. Thank you. And I forgot. Yes. So this is the printout that the CC crate did to debug, inform me that it compiled my code with this command. And there's a bunch of like, do I know what M64 does? No, I actually don't remember what that does. I could imagine it has something to do with the size of an integer, but I have no idea. A bunch of warnings, cool, fine. So there's all these details, and we just don't have to care. Thank God. Until sometimes you do. So, right. So the question was bindgen. So if we had to live our lives doing this, we would be pretty fine for 4 or 5 simple functions, right? Yeah, I can declare add 2 and add 3 and add 4, and life is fine. I could probably remember how to declare print. But if you have a beefy library, which is often, maybe, hey, you want to call, the zlib, or you want to compress some stuff, and you have a C library that implements compression, and you're like, I want to call that. Well, zlib, there's already Rust bindings for it. You should just go get them from crates.io. But, in general, you've got some library that has like a beefy API, and you want to call that thing. Figuring out this stuff, first of all, it's a lot to type, and it's really annoying. Second, if you make tiny mistakes in this, you're screwed. Like there's a reason that all this, when you call these things, they're all actually, you're not gonna see it until you get to my tests, right? Wait, I want to say everything's unsafe. Where did the unsafe code actually live in this case? I should know. It's add 2 is right. There it is. Right. Okay, cool. Has to be somewhere, right? Yeah, so add2 is a C function. It's unsafe, and you have to call it inside an unsafe block. And part of the reason for that is because C functions can do anything, and they can just corrupt memory if they want to. But the other, one of the other reasons for that is if we got the definition of this function wrong, maybe we swapped the arguments, maybe we got the wrong argument type. Who knows what's happening? The Seattle Rust user group has a tendency to become Seattle Assembly user group. That's kind of like our final form. And I'm not going to do that today. But if we did, we'd see like, oh, the instructions that get omitted when you call this function depends on what types you said. And just everything goes off the rails, right? If you say the types wrong. So this is really, really, really annoying when you have to do a lot of it. And so, as per his excellent question, there is a tool that automates this. So if there's one thing you memorize from this talk, memorize CC. If there's two things you memorize from this talk, memorize CC and bindgen. So we're going to jump into slightly more interesting pile of C code, just to kind of motivate bindgen a little bit, have a couple functions for it to generate for us. And that bindgen is ultimately going to look like this. This is what our build.rs is going to look like. We'll get to that. Let's look at some C code. And I acknowledge that folks who have not written C at this point, I'm probably going off the rails. But for folks who write C frequently, hopefully this is the simplest data structure I could come up with. So it's sort of like a vec, but it's just got a fixed capacity, so what am I saying? I'm saying capacity 10. All right, this vec can hold 10 elements. Easy. But of course, because C does not have the C++ or Rust or even modern Go style generics with whatever bracket you might choose to use, it doesn't have that. So in C, we often use void star, which, again, I know I'm going off the rails for half the room, but void star is like a pointer to something. I don't know what it is, right? You give me a pointer, and then when I give it back to you, you cast it back into whatever it was. That's what void star is. And a lot of generic data structures in C will use void star because C doesn't have generics. So what have I done here, right? So the struct contains two fields. This is the buffer of 10 void stars. That's array syntax in C, right? And I have gone ahead and said how many we actually stored there instead of forcing the caller to remember. Okay. And I've declared my two functions, push and pop. Over here in the actual code, the C code, here's push. I chose not to do any bounds checks here, not because I couldn't have. It's not C's fault. It's my fault. But I'm lazy. We didn't do any bounds checks here. So we're just, without checking length, we're writing to the next element and then incrementing length. So you could totally buffer overflow with this function, and that's my fault. Pop, we do check. I figured we're returning a pointer anyway, so we might as well return null if it's empty, right? So if it's empty, right, we return null. If it's not empty, we decrement the length and return the last element. Questions so far? Push and pop from a fixed length, fixed capacity, I should say, stack. Simplest data structure I could think of. That wasn't a linked list because we're not going to do that. So here's build.rs, and half of this is nothing new, right? So yeah, cc build file, please compile it. Great. And there's some directives, and in this case, we do have a header file, so I did it twice. But we saw all that before. New thing is this. So bindgen is going to consume our header file, and it's going to spit out that extern C stuff. It's going to translate it into the Rust. It's not code, really. It's like declarations, right? We give it, right? And this is, and unfortunately, there's just a bunch of noise comes after this. It's like, where do you want me to put the generated code? I don't know. Here's this magic environment variable right to that file. And when you include the code, we skip ahead. It looks like this, which is a bunch more magic nonsense that no one is ever going to remember. What you actually do when you use this is you Google bindgen, right? So you say bindgen. Okay, great. Oh, bindgen user guide. Cool, cool, cool. And then you're like, da, 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 da. How do I include the generated code? Like this. Okay, like this is what you do. You don't remember this. So this is the sort of this reminder of how we're actually going to pull this file in. I tweak it a little bit, but you can copy paste this. And I think I probably skipped where they, right. So what do they do? This is sort of where I got the part that generated the file. And again, I've tweaked it. There's little differences. You can change little things, but that's what it's going to do. And you can see the exact same magic. Read some environment variable to figure out where to put the file. It's a little bit random. So we Google it when we need it. But that's sort of what's happened here. The important thing is I've taken a dependency on bindgen. That's a build time dependency. Folks may have seen that you have like normal dependencies and you have dev dependencies, and then there's actually this third category, build dependencies, the dependencies of build.rs, possibly other things. How am I doing for time, by the way? Maybe got 10 more minutes, 15 more minutes, something like that. Okay. So that has generated something. We'll see the whole thing. But here is the cleaned up version of what it generated. So this is familiar, right? How do you generate declarations of functions that are implemented in C? Unsafe extra in C, whatever that means, right? And there's some assembly nonsense that it implies, but we don't worry about it. And you know, the void star has this like really long type, but okay, fine. And everything else is just the arguments, I think. Sure, plausibly. Right, this one returns something, this one doesn't. Okay. And then, of course, now we have a struct, right? So we've translated this struct definition from C into Rust. An important piece of noise that we do see at the top, repr C, right? So the same way NoMangle was kind of dealing with some mysterious differences in how the linker expects C functions to be named, repr C is going to deal with some mysterious differences in how the compiler in C and the compiler in Rust like to lay things out in memory. And we don't necessarily need to know the details, but it's pretty clear in this case, we're saying do it the C way, right? Well, that makes sense because this is coming from C. So we should probably do it the C way. And this is the Rust array syntax, maybe a little bit more familiar. The bindgen always spits out like the explicit like usize suffix for the integer, which is unnecessary, but maybe like clearer to someone. I only ever see this in bindgen output, but this is normal Rust. You can do that. Any questions about the code we see here? You'll notice that capacity became a U32. That's a little funny, but it wasn't even an integer in C. It was a macro, so it had to pick something. So those little funny stuff. Let me show you the real thing is unfortunately a little bit noisier. So if I go to my code here where we're going to test this, and if I say, I call it FFI. I like to define an FFI module. You can do it different ways. I call it the FFI module. If I go to definition, that takes me to the actual output that wound up in my build. It's a bunch of crap. I don't even know what a max align T is. We see a bunch of these. I'm going to zoom out a little bit. We see a bunch of these weird const declarations, which are actually tests. You should think of those as tests. There are like asserts, basically, that the types are the size that bindgen thought they should be. And then you see, okay, yeah, there's our struct definition. We saw that. Some more random tests. There's our functions. So that's what it actually looks like. It's full of noise. But the noise is there for a reason, I guess. Any questions about this? So where am I going with this? I gotta remind myself. Right, so we copy pasted from bindgen docs without worrying too much about exactly what's happening. It is possible to read this. All of these things are turning off warnings. That's what allow does. We could have deleted that and we would just have a bunch of warnings because C's names aren't the same conventions as Rust names. Include works like include in C. This is like, hey, please actually literally copy paste this string into like the source code here. What string? The concatenation of the value of this environment variable and, oh, excuse me, include takes a file path, not a string, right? So, right, concat is constructing the path. Okay, we don't care, right? Something. But it's being included in that way. This is, cutting off the screen. Well, I thought it would fit. It doesn't fit. So now on the Rust side, we have to start wrapping these types that we've been given, right? So in Rust, you know, I don't want to deal with an array of void pointers, raw pointers or whatever. I want a nice, safe type with safe methods, right? That's how I want to use this thing. The Rust is good at. So what am I going to do? Well, I'm going to declare my own type. Okay. And in this case, it's just got one field, and that field is the other struct. Okay. Put a struct in a struct. I heard you like structs. And what do I do? In this case, maybe surprisingly, we can initialize this whole struct with no unsafe code. So there's no unsafe on this slide. The struct has two fields. Length starts at 0. Makes sense. And then we just create an array of null pointers. That's that. And you can create, this is a raw pointer, but you can create raw pointers in safe code. Funny thing. So nothing crazy here, except I believe we're going to see a compiler error. Yeah. So this sort of, you run into this every time you play with this stuff, right? So like when you're dealing with raw pointers to things, you always run into this obscure compiler rule, which says that if you have a generic parameter t, it has to actually show up in your fields. And there's like reasons for that. And if that could be a whole type, a whole talk of its own. that has to do with lifetimes do funny things and the send and sync traits do funny things, and we can get into it. Feel free to ask questions, but the actual thing you need to memorize, if you were going to memorize 3 things, don't memorize 3 things. Only memorize the first 2 things. But if you had to memorize something else, you can memorize phantom data is how you solve this problem. The compiler will also hint this to you, and you just paste it in there and forget about it. Now, of all the things we're talking about today, this is the most like kind of unfortunate, like maybe it could have been simpler than this detail. And we just have to do this. Phantom data contains nothing. You create it with no contents. It just says, treat me like I hold T. And I'm not going to say any more about that. You'll run into it. The compiler will hit you, hey, phantom data. And you'll be like, oh yeah, I saw it on the talk. And you paste it in and you'll forget about it. And it's fine. But when you get to around to reading the Rustonomicon, there are actually some interesting topics here.
I think I'm
Yes, as Brad mentioned, phantom data is a 0 size type. So we pass no data into it when we create it, and it contains nothing. And in Rust, types that contain nothing are 0 bytes in size, which is actually not true in C++ at least. C also, yeah, for compiler magic reasons. Okay, so no unsafe code needed. Phantom data, whatever's going on there, we're not going to look too hard at it. Now we can wrap those functions, right? We want push and pop methods. I was lazy in C, and I did not bother to do a bounds check. I could have, but we're going to go ahead and do a bounds check here. So we're just going to assert that we're not overfilling this container, right? If we try to push more than 10 elements, panic. Fair enough. At least it's safe. And then the next thing we have to deal with, and this is probably the most advanced or sort of like niche, point here that we're running into, is the C code wanted void star pointers, right? It doesn't know how to deal with objects of different sizes and different types. It just wants you to hand it a pointer. I saw the question or no? Maybe not. And so if we want to take an object that we own and keep owning it, but we just want it to be behind a pointer, which folks who know what the heap is might know that that means it needs to be on the heap. In Rust, we do that with box. So box says, I'm going to do what C would call malloc, basically. I'm going to allocate some memory on the heap. I'm going to put this thing in there. And I, the box, am a pointer, basically, to the thing. And then we can get that pointer in raw pointer form. There's various ways to do it. In this case, I'm going to do it with a funny method function, actually, yeah, standalone function called leak, box leak. So normally, when the box is destroyed, when it goes out of scope at the end of the scope, so normally when lm box goes out of scope here, it would normally free that memory, right? Most things in Rust that allocate memory free it when they go out of scope, very similar to C++. We don't want it to do that because we're going to take that pointer and put it in a C structure. And if we free that memory, now we have a C structure full of garbage pointers, and we don't want that. So box leak is going to say, do not free this memory. And it happens to return a mutable reference to T, which is a little bit funny, but it turns out to make a lot of sense. It's a mutable reference to T whose lifetime is static. It's one of the funniest type signatures in all of Rust. And we can cast that mutable reference into a raw pointer and into a raw pointer of a different type. And the reason it is called box leak is if that's all we ever do, that memory is leaked forever, but it's perfectly valid. We'll talk about freeing it later. And then we call our function. Pop is the reverse, right? So we're playing the C pop function. We're getting a raw pointer back. Turns out that the way you check for null is the method in Rust. Fair enough. We're using the Rust option type to represent that thing that might be there or might not be there. I know not everybody has seen that, but that's a very common type in Rust. And then in this case, from raw is sort of the inverse of leak, more or less the inverse of leak. So I'm saying, hey, here's a raw pointer. I know I got it from a box. Please recreate the box that it came from. And then funny little detail, we dereference that box. We pull the object out of the pointer. That consumes the box. Box is the only type that does this in Rust. It's a little bit special. And we have the object. Any questions about that? Is it really copying our thing over to the heap and copying it back? Yes. Yes, it is. So box new is semantically a copy to the heap. In many cases, we would hope that the compiler sort of notices that it's creating something on the stack and copying it to the heap and maybe just creates it on the heap. but that's up to the optimizer. And this dereference and I guess the implicit move that retrieve entails is copying from the heap. I realize that I'm throwing like a lot on the screen. We're basically done. One little detail. Hey, maybe we should free some of this memory. So in this case, if I go back, so if we do pop elements, we're pulling them out of their boxes correctly, I claim. I did test this code. And so we're not leaking memory. Like we're pulling those objects back to the stack, basically. And that's great. But if we left some objects in this short vec, they just get leaked. So we might want to have a drop implementation that avoids that. We don't need any more unsafe code to make this work because we already have pop. So we just pop until we're empty. So this prevents a little memory leak if you stop using a short vec that still has stuff in it. And I believe the very last slide is a nice little command. Yes, so I can run, we'll come back to this. I can run this code. So as before, it's the code from the slide. We've already seen all of this. And I threw some tests in at the bottom. Whatever. So we can run that. The tests do pass. One thing I want to demonstrate, and then I'll take final questions and get off the mic, is so we see this function test drop. All it does is push some integers into a short vec. But we can remember that those integers are getting boxed and then passed to C as void stars. So they are integers that will be heap allocated, even though an integer in Rust is not heap allocated. And then it just drops V. So if I go up here and delete this drop impl, get rid of that. So now we actually do expect those things to leak. And if I go back to my, let's see, we don't need the man page. We don't need to let out. But if I go back here, those tests will not fail. Not the first time. So leaking in Rust is not technically undefined behavior, and it doesn't cause any crashes. But this last command here on my last slide is a great way to go find your leaks if you're doing a bunch of C code and worried that you might have created them. This is going to turn on the address sanitizer, normally a feature we use more in C. Very useful in C, often useful in Rust when you're calling C. You have to turn it on both sides. It took some Googling for me to figure out what flags to pass here. And I don't remember. I have to go back and look at the slide whenever I do this. If I run this, remember, I've deleted the drop impl. So those 3 ints are never getting dropped in this case. We should get a giant crash, and we do. And that crash is saying direct leak of 12 bytes. Did I expect it to be 24? Kind of. It's a little weird. That's right. Right. The pointers are 8 bytes each, but the ints themselves are 4 bytes each. Of course, that makes perfect sense. Right. We put 12 bytes on the heap, and we didn't do anything with them. We forgot all about them. But right, that's the deleted code. If I get rid of that, deletion, if I put the code back, get reset, and then I rerun the test with address sanitizer, they pass. So ASAN is normally, we use that for like dangling pointers, right, or garbage pointers, right? It helps us detect those things. It also detects leaks, which is pretty cool. So that is calling foreign functions from Rust. I realized that was a lot. My main goal was to kind of plant little seeds so that if and when you decide to do this in the future, you're like, oh, there was a slide or something. And or maybe the second or third time you see it, it kind of sticks. That's sort of how this stuff tends to work in my experience. Thank you all for listening. Any questions before I hand over the mic? Go ahead. Yeah, if I could summarize the question, tell me if I get this right. The question is sort of what's happening to the types here? Like, could we mix different types? How does this integer type, or the C code doesn't know that it's an integer? What happens? So we can trace it. So I think go to definition might actually work. That would be, God, I love living in the future. Okay, so right, so T is still an int, right? So Rust knows that T is an I32. I think it defaults to I32 down there. Yeah, those probably default to I32. Right? So kind of a funny little detail that only shows up in little tests, but. So that T is still an int. So box new of LM, so that's a box of int, a box of I32. That's still got it there. And then so when we leak it, let's go to definition of box leak. It's a little bit easier to read in the standard library docs, but this is good enough and it's in front of me. So leak returns a mutable reference. It's actually, right, it's not even a static mutable reference. It's a mutable reference whose lifetime is totally unconstrained. Such a funny thing. It could be a talk all of its own. But it is in practice, you can treat it like a static mutable reference. And so that's a mutable reference to I32. So T is still there. And then we cast it to a raw pointer to I32. So I32 is still there. And then we cast away the type right there. Okay. Yes. Yeah. The question is how you, right. So if let's say I just try to push a string is sort of what the question, right? So if I try to push a string, that is definitely not going to compile. And the reason it's not going to compile is that short vec, has a type T, and that needs to get inferred by the compiler. I could have specified it, but here it's getting inferred. So the compiler takes one look at that. It's like, oh, T must be I32. I think that is correct. I think the compiler looks at the first push and infers T. I'm sure someone in the audience would be like, it's technically the last push or something. I don't know. Hindley-Milner type inference, the buzzword you're looking for.
Whatever, right? HM type inference is actually very predictable. And in this case, it is looking at the first one. And then if it encounters another type that is not equal. But this is actually called type inference.
Right,
Is that in Rust or is that in C?
This is Rust.
This is only in Rust. And
no,
yeah.
No,
This is
Seems like whatever, bro.
Yeah, whatever.
right, Void Star.
Yeah.
Yeah, so this is like Haskell stuff. Those of us who like complicated programming languages. Yeah, so Rust knows that short vec needs to have some type T, and if it can infer that from context, it'll be happy, and if it can't, it'll just yell and scream, and if it's inconsistent, as it is here, it'll yell and scream. Say what?
You could mix
You, you cannot. Yeah, we can't mix types like this. Now, Rust does support what's called dyne trait or dynamic dispatch trait objects. So you can start doing some C++ virtual kind of stuff. Different talk. Ben.
Suggest when you're using bindgen is run cargo doc -- open
Huh?
and see the docs that are generated for the C code that was generated.
Let's try it. So cargo doc, yeah, if you have seen the -- open flag, if you haven't seen it, very convenient, just pops it open in the browser. Oh, not in the right, sure. I have too many projects in one repo, yeah. Okay, so there's my short vec. We saw that, bunch of auto traits that we don't care about. Ah, okay, let's try that. So this module that's being like sort of populated full of generated code, we're gonna try to make that public, see if that helps. Oh yeah, okay. Neat. So we've got auto-generated docs for our C functions. So like, do you think if I went and hit in here, I don't want to take too long. If I put, actually I should be in the header file. If I put a comment above this, do we think it's going to show up in the Rust docs? Probably not. Triple slash? Well, triple slash certainly won't break anything if double slash is working. So let's run with that. Some stuff. I think I put the rerun comments in the right place. So FFI, what function did I annotate? Look at that! Oh my God, I thought it wasn't going to be there. Sick. These and other expert tips you find at the Seattle Rust users group. Yeah, gross. All right, thanks, y'all.
Okay, it's on. It works.
Cool.
All right. All right, so I think. Good. All right, so we're going to get started again, and Sam's going to give us a talk about shipping Rust to Python, TypeScript, and Ruby users. Take it away.
Hello, folks. What's up? Okay. Yes. Do I need to join the Teams call? Okay. I will pull up Discord then. Oh, I'm not on the Wi-Fi. I just realized that.
Wi-Fi up there.
All right, so if you join that,
Let's make that 35.
you're going to go to blue. You read the red marker. Capital reactor / capital aesthetic.
Cool.
You'll get to then you go to this HTTPS. But I think it should still do it. Generally, it should still open up perfectly. You want to join with muted audio and video to see. And at the end, they wanted to drop messages flush for the other threads. Just make sure okay.
Huzzah!
Then you can share. Repeat.
Beautiful. All right. I think we're in now. And if I find my slides again, there we go. All good now? Thank you so much. All right. So shipping Rust to Python, TypeScript, and Ruby users. Probably a terrible idea. And that's what we're going to talk about. AKA spreading the glory of Ferris or gospel. Please ask questions. I'm going to hit a lot of different things. There are going to be topics that you don't know about, that possibly I don't know about, and I would like to answer as many questions as possible so I leave as few people behind as possible. Doing this, you probably shouldn't do this, but sometimes you do have good reasons. And if you do have these reasons, you will need to make some decisions. And I'm going to walk you through all three of these stages. Why you shouldn't do this, why you might want to actually do this, and then like what I'm going to spend the most of my time on, kind of the questions that you want to think about as you're going to do this. So Jack talked a lot about like the low-level details of like the very lowest layers that you can be involved in here, right? C underpins all of like Python, Node runtimes, Ruby runtimes, and is like kind of like the lingua franca of like low-level computer stuff these days. All of my stuff is going to be like 5 layers zoomed out. And I'll zoom in a little more in some of these slides, but not too much. So the first part, reasons why you don't want to do this. There are pitfalls. You're going to run into a lot of things. Jack very sensibly did not try to do very much live demoing, because the moment you try to do live demos with any of this, or if you try to do like anything like involved, you very rapidly just run into like screens full of compiler errors. I think this one was specifically because I forgot to copy paste one line of code into a build.rs file, and I can reproduce that very easily because I remember exactly which line I had to add back in. And like, we kind of know what compilers are. Like, we've run cargo build. Linkers are a thing that like you see when you run Rust, when like a Rust error happens, like you decide to like cross compile your Rust code for some platform, and then it yells at you about ring, and you're like, what's a linker? Now I have to like learn what a linker is, and it's not particularly pleasant. Your release process gets way more complicated. This was our release process like I want to say a month ago. There's now like 3 more boxes on this graph right now as of like 3 days ago. And you can kind of see the pain that one of my coworkers went through. Try package this, set up NPM, blah, 2, fix packaging paths, fix Windows thing, add more targets, FML, retry, fix version, fix packaging, more tries. It's a lot of pain. Not shown here is that each of these runs is like 15 minutes. Anywhere between like 5 and 15 minutes. And like the iteration method is pressing git push, cracking open the GitHub UI, and just watching your workflows fail and be sad when they fail. You will also learn things you're very much happier not knowing. When I went and did the Ruby stuff for us, Ruby has 1, 2, 3, 4, 5, 6, 7, 8 different ways of passing arguments into functions. Rust has 1, thank God. And fun fact, if you want to write interrupt code between Rust and Ruby, you kind of need to be aware of like what each of these things are. So like kind of like linkers are black magic. Every one of these types is its own form of black magic, which is like, sometimes we like logic puzzles. Other times we would like them to not be in the critical path of our work. So that's all the reasons why you don't want to do this. Why you would want to do this, to be a little bit more serious. If you want to support languages, if you want to support your users in multiple different languages, right? People use languages that they've learned. People use languages that they're productive in. And people use languages because sometimes the ecosystem in one language is a lot more well suited to their purpose than the ecosystem in a different language, or just because like they find it easier to hire Python developers or TypeScript developers than Rust developers, right? Like it's easier to hire them. There's a lot more people who learn these languages like coming straight from like no technical background. And so like if your users are in a lot of these communities, then you kind of want to go to where your users are. In our case, so I work at Boundary ML. We build BAML. We build a new DSL for calling LLMs and providing guarantees around what LLMs give you, the shape of the information you get back. All of the people that are building LLM-powered applications write their code in Python. They write their code in TypeScript. They write their code in Golang and Rust, occasionally in Rust, Ruby, all sorts of different things. And so the reason that we did this is we said, okay, we want to be able to build our software so that people in all these different ecosystems can use our stack. But we also want like to retain our sanity while doing so. And Go is actually in the works right now. But kind of like what I'm showing you right here, right, is like this is BAML code up here, and down there that's Python code. You have autocomplete in Python out of our BAML code. And like the reason we're able to do that is because of Rust. And like we can do exactly the same thing across TypeScript. We can't really do this in Ruby because autocomplete is a lie in Ruby. And for some reason they haven't fixed this in 20 years, and I don't really ask questions. So that's one side. So polyglot use cases. The other reason is that Rust lets us move fast and not break things. To give you some more, to make this very concrete, So we're small, we're seed stage. We have 6 people total. Our 2 co-founders wrote their first Rust code in October 2023. So we're talking like 18 months ago. I joined February of last year. I started writing Rust in December of 2023. So I've got less than that under my belt. We're now a team of 6, and our default to this day is to not do code review. And we're past the 100,000 lines of Rust. I think most of us like who do like any kind of things at like a team with like many people very quickly realize like, hey, if I want to know what you're working on today or tomorrow or in 2 weeks, like we need to do code review so we can know what's going on. Because of the things that we can just encode in our source code by virtue of like Rust compiler guarantees, we can actually do this. And we don't really have bugs around the shape of like our data. And it's worked for us. So now that I've kind of given you like a sense of like the whys, the why nots and the whys, let's take a look at some code. So you can go to that link to check it out. I will flip over to an IDE to actually show you what's going on here. So this is let me magnify this a little bit more. This is some Python code, right? We've got main.py, we've got hello from my Python app, and I will flip over to a terminal, and oh god, I forgot my up arrow does that. I'm gonna do this very involved command. And so Jack showed you like the cc build command and like the magic that was in his build.rs. This is like the manual version of doing that. And oh my goodness, why? What is okay? Oh, because I'm in the wrong direction. Okay, I'm just gonna do this is the hot reload command that I have. So we have hello from my Python app. What I'm now gonna do is uncomment this line, which is calling into a Rust crate and telling it, hey, I want you to run a web server on port 3000. So now this thing, it's already run hot reload, Rust HTTP server, listening on localhost 3000. If I curl this, I get a Pong back. And I can hop back into my Rust code and I can see like, okay, apologies for like the massive thing that I'm about to show you. But essentially like the one interesting line is this line right here, right? Pong from Rust crate. Pong from my Rust crate. And if I modify this, whoops. Pong, pong, pong. Watch it rebuild. My Rust server is listening again. I can curl again. I have pong, pong, pong. I have Python code calling for Rust code. And if I really want to like do some wonky stuff, I can even have a stream going, right? That's the reason for like the rest of this, like all of these shenanigans, because like you can do all of these things. So that's what the scope of things you can do. And like you can imagine like anything that is available in a Rust crate, from like TLS parsing stuff to crypto primitives. Jack's the maintainer of Blake Free, which has been exposed through PyO3. Other like someone a few weeks ago talked about like exposing some matrix analysis stuff. The folks over at Polars have been working on a pandas replacement in Rust. So there's a whole bunch of things, right? Basically it gets you, hey, Python doesn't have types. It's hard to be confident sometimes about exactly the guarantees that you have and communicating to them to each other when you're working in Python source. It's a lot easier to do that in Rust, and let's just do it in Rust. But now you have questions, right? So the first question that I would recommend you start asking is asking like what kind of API you want the users of your library to have to work with. If you use Rust objects, and the same, all of the rules of thumb, by the way, on these slides, I'm going to use Python for most of the examples on the slides. I'm going to use Python demo code, but the concepts are the same across all of them. And I can say that because I've written all of them, and I can actually bounce through some of the code, some of our production code to show you this. But if I use Rust objects, assumptions that you have when you write Python code kind of just go out the window, right? If you write a class in Python, a thing that you get when you write a class in Python is you get a constructor. You can go and say like, yeah, I want to build a list of like 1, 2, 3, 4, 5. If you do that in Python, sorry, if you do that in Rust, you now have to like define your Rust constructor and expose that to Python. If you want to be able to print an object using str, now actually, I think I have demo code in here. I prepped a bunch of it, and I prepped it as a I prepped it as a grab bag of kind of just like, here are all the things I can do. So let's go and do that. So I'm adding my Rust object back in. So that is this thing right here. So I have a Rust struct. It is annotated with PyClass. I have a bunch of methods on it that are annotated with Py methods. And kind of like along the similar lines, like we mentioned, Jack briefly alluded to this, that your foreign function signature has not a lot of strong intrinsic guarantees on what you pass into it, and that bindgen can help like reduce a lot of that boilerplate. That is the same across all of these libraries. There will be a lot of, shall I say, magic in the annotations for each one of these libraries that will kind of just do the thing that you want to do, with the caveat that you may still have to copy paste things more times depending on how many people have used the library and done the work of like reducing the amount of copy pasting that you have to do. But now that I have this, I can go and find my Python tab somewhere. It's in here somewhere. And I can do my Rust crate dot my Rust object dot my static methods. Hopefully that returns something. Argument missing for my parameter text. I did something there. What did I do? It's supposed to take a text thing. Right, because my object, okay. So here, Python text. This one? Oh, yes, this is coming out of Pyrite. So I am actually, so this is effectively VS Code. Pyrite is the default Python extension built in VS Code. There is also, like, I will also note, just like how we were amazed that comments got propagated across the bindgen boundary, type annotations can get propagated across the Py03 boundary. They do not get propagated across the Ruby boundary because types are a lie in Ruby, and there are 4 different type systems in Ruby. And in TypeScript, you do have types, but then you have to muck with TS configs, and it's a little painful. Python's actually impressively the easiest one to make work. So now I have Python text, and I'm gonna do this. Who has any idea what printx is going to do? It's gonna call stringify. So, did I? Because I'm still starting a Tokyo server, so it's never gonna get there. So now I'm gonna zoom in a little bit more, actually. So printing that gave me this jumble of thing, which is not really useful, right? Like if I want to debug anything, I don't know about you, my first resort is like printf. My first resort is like just go into the object, see what the heck is in it, and print it. And this like very basic assumption, right? Like I can do like d equals like asdef lorem ipsum. And like there's like no like true, there's no like single truth for the way you should print out a map. We all have different formats we want to print stuff out in sometimes, but like Python by default, like one of the reasons people use Python is that you can just like print stringified versions of random objects in Python and it'll just work. If you do that with Rust objects, now you have to like go and do it yourself. So you can go and add, you literally have to go and add like we're talking about magic. We're gonna see some magic. Sorry, can it be what? That's a good question. Let's find out. Yes. So the question was, can __ str return a just string instead of a pi result of a string? And I just need to actually clone that. And I believe it will actually work. Yeah, there we go. Created by static method, Python text. So alluding to that point, right? Like everything in Python can fail. Any single like instruction, quote unquote, in Python is allowed to just say, nah, I'm gonna explode. And so like we can do like just pi result. Pi runtime warning. This is a runtime error. I think that may work if I import it, or if I wrap it in an actual error. There we go. Now I have a runtime error. But coming back, right? Like these are all things you now have to do by hand in Python in Rust, right? You have to implement your string representation. If you want to give more information about like if you want to do like the Python version of the debug traits, you have to implement repr. If you want to be able to use your object as a key and a dictionary and a map, you have to implement hash. If you want to do things with pickles, so Python has this like magic thing where you can say like, okay, I'm going to dump out all my variables to a file and then be able to load them back from a file. You use pickles, and you have to do magic for that. The sad thing is that like even if you don't want to do this, there are libraries in Python, including in the Python standard library, that will magically do this for you. And you will be very, very sad when you learn about this, because you're going to find yourself like 5 layers down the rabbit hole and then be like, oh, it's pickling. And we didn't implement pickling on our very convoluted singleton object with thread pools, and now we're sad. Similarly, in other ecosystems, right? Like the same thing exists. In Node, if you want to support like JSON.stringify, which is basically like their version of print for complex objects, you need to do this yourself. If you want to support destructuring, kind of like, so they have their own version of like destructuring as in Rust, or unpacking whatchamacallit. You have to do that. You have to think about like whether or not your objects are going to be compatible with that. Because if you just write a Rust object and you hand it back to a user in Node code, it's not going to support destructuring. It will maybe support JSON.stringify if you remember to implement the magic method that needs to exist on your Rust object for your Node user to be able to use it. But like it's not well documented. It's like kind of buried somewhere in documentation. Ruby objects, if you want it, and it's the same thing. The flip side of this, right? So that's one side of this decision, that you can, whenever your users interact with your library, you hand back an object that your library created, and it's a Rust object, right? Like it's all the logic is your constructors in Rust, all the method calls are in Rust, and like they don't really get to interact with native facilities unless you build that yourself. The other way to do this is you say like, okay, you can just pass in a string from Python, and we'll do, or like a random like class object, and we will do whatever we need to make it work. What will happen there is now you need to go and do all sorts of error handling. And someone asked the question at the end of last talk, can you pass in an arbitrary value across the Rust C boundary? All of these languages, right? Like you can say like, in Python, you can go and say like, oh, D is a dictionary. Well, D is now an integer. I'm going to print D. And then you can go like, hello world. And ignoring the runtime error, but like we saw D go from a dictionary to an integer to a string. This is a bizarre concept for those of us in Rustland, but Python is a different language. Python is a different world. This is a thing you are allowed to do in Python because there is a Py object that just encapsulates all of these things. And what happens if you decide that you're going to allow your users to pass in anything that they want is you have to start handling all of the cases yourself. You have to ask, oh, did my user pass in a false value? For some reason, false in Ruby is a singleton. It's not an actual Boolean. I don't ask questions. You get to ask, is it an integer? Is it a float? Is it a string? Is it an array? And then you have to do all of your own dispatch on top of that. There are Serde like things that you want to. There are Serde libraries in each of these ecosystems that'll allow you to basically say like, okay, if your thing looks like a JSON object, you can just use Serde and deserialize it into the thing. Unfortunately, if you've ever dealt with a Serde error and stared at it and wondered why it was failing, Serde errors are, they'll complain. They will not give you all the information you want sometimes. And at least for our cases, we were not happy with the errors that Serde did. We ended up handwriting a lot of this code, and it was painful. Even further, if you want to do anything with async, your life gets real complicated real fast. So the easy answer is to like just not deal with async stuff. Or if you do have to do with async stuff, be super lazy about it. Build a runtime and just tell the runtime like, hey, do the async thing and then like pretend to be sync. This is what we did in our Ruby code because we only have so many Ruby users. And fortunately, like they're running in like serverless environments, so like they don't really need to worry about concurrency too much. But like this is one way you can do it. And I believe rest. I meant to hop back to code at this point. However, if you do this, what did I want to do? I wanted to do this. I'm going to delete all of that code and go back to this. So I'm going to start my server via Tokyo. I'm going to delete something that was very, very important. So I'm back to running my server via Tokyo, passing it, exposing it from Rust to Python, and start server via Tokyo does literally this. It creates a runtime, and it says block on the implementation of my HTTP server. And it's just going to wait there. And now, I may regret this. I think I have to switch directories to be able to do this. Error while binding to address. Address already in use. Ah, okay. Let's just change the port. I can leave a program just hanging there forever. This is going to be very sad when I press Control-C. And I'm just pressing Control-C over and over and over again, right? Because what's happening is that in this code, right? This is a blocking Python function call into Rust. And Rust is just saying like the Tokyo runtime is now in control of everything. So Python, which is by default listening for my Control-C, cannot do anything. Python is supposed to be listening for the Control-C handler. And now I'm kind of screwed because I have now shipped async code to my users and they're like, hey, I can't stop your program. How do I get out of here? So the sad answer to this is that you have to tell them like, hey, sorry about that. Oh God. I'm gonna just minimize that real fast. Yep. Oh yeah. I'm going for kill-9. That was more processes than I expected to be running. That was possibly not the right process. We're gonna, all right. Until morale improves. Well, fortunately, I can just do kill pain. And we will CD back into there. So now, if you're taking this approach, if you're saying that like, okay, my Python code is just going to call my Rust code that's completely taken over everything and is now completely unresponsive, you now get to install your own signal handlers, right? Which is like the point of doing this is like to not have to do, like, I said you were gonna have to do funky things. This is a funky thing you may find yourself having to do. But now, and this is gonna fail because I'm in the wrong directory. Also, note the length of that command, right? Like, there's black magic involved. You will not fully understand everything. This is a thing you just kind of have to live with. But now I can Control C, and voila, I can kill my Rust program. Yes, I return. Yes, I am now returning control to Python. There are better ways to do this. Or okay, actually, first thing I should talk about. The reason that this goes haywire, right, is because every one of these ecosystems, if you're in the Python runtime, if you're in the Node runtime, if you're in the Ruby runtime, every one of these ecosystems has their own signal handlers that if you're running Python code, they install their own signal handlers in the process. Those signal handlers are the things that are supposed to be running. If you take over that signal handler manually, you may do bad things to the other Python code in there. The libraries themselves will kind of provide bridges. So again, or I alluded to this earlier, but if a library is more popular, there will be a richer ecosystem around it. People will have done more work so that you don't have to do it. You don't have to copy paste as much code. So if you're in Python, there's a Pyo3 async runtimes library that will just magically translate a Tokyo future into a Python future-shaped thing. Node will convert Tokyo futures into promises. Ruby, there is none. If you're in Ruby, you're sad. This is why we do our stuff in Ruby synchronously. The only people we know of that have actually done this are the folks at Temporal, which is like persistent workflow engine, and they like hand rolled their own thing. Yes, question. That is, yes, I will definitely take you up on that, or someone at Red Hat possibly. But to show you what this actually looks like, so there is another version of this down here. Start server via async IO, Pyo3, async runtimes, Tokyo, future into Pi. Again, a lot of incantations, just things are happening under here. But I will note, right, that start server impl is an async function. So what this means in Rust is that it's actually returning a future, right? There is this magic type annotation that shows up on async functions. And I can use future into Pi to just convert this into a Python object that in Python is a future. From Rust perspective is just another Python object. And I'm not sure why this is complaining about it being unused. Oh, because I haven't exposed it. That's why. And now, if I go, or actually, I'm going to uncomment my Control-C handler. Remember, right? This was the thing that allowed me to actually Control-C my process. So I will also have to start server via async IO. I will now have to do this stuff. And I believe, yes, I also have to do async IO.run. Because async code in any language is painful. And now I can still curl. I will have to 3001. I can get pong, pong, pong. And I can Control-C. And it just worked under the hood. And the reason for this is because in the source code for this library, do I want to go and do that? That'll be fun. Let's do it. This may be risky. Source, it's a little wonky down here because there's a thing the library supports both Tokyo and async standard, but I believe cancelable. And deep under the hood of like what this like future into Pi function, it goes down kind of like Jack went down the rabbit hole with like right and right and right and right and right. And if you go deep enough down the rabbit hole, you eventually end up here in this place where it's doing things with the Python GIL, global lock, and it's doing things with cancelable and says like, hey, if a cancel happens, kill the future. And that's how like this library is doing the async bridging. Control-C somehow works in Nappy in our node bridge. I'm actually not totally sure how, because when I went and looked at the code when I was prepping this talk, I got very confused by exactly how that was getting propagated. I just know it works because we've had users do it and we do it ourselves. So like, in terms of how it works under the hood, this is another thing, right, that you have to start asking questions about like whether or not this is the model you actually want your users to deal with, and maybe you have to deal with it yourself. But essentially, what happened, the very high level hand wavy process of async in Tokyo, is that you have a loop, you have a bunch of tasks, you put futures into it, and you just say like we're gonna just loop over this queue. And we're going to do a work item on this queue. And they all of Python, Node, and Ruby have their own versions of this. How am I doing on time? 5 minutes? Perfect. That actually ended up being really close. I was concerned about my timing. And all of these bridges, in Python and Node, they exist for you. In Ruby, you kind of have to do it yourself. Also, again, I mentioned Ruby has 4 type systems. They also have like 3+ async systems because there was a different one every 5 years, kind of like front-end frameworks. Celebi. And in order of difficulty, to wrap up the point on awaiting Rust futures in Python is just that you have to bridge these somehow. You should spend a little time, if you ever do this, thinking about and understanding how exactly it crosses the boundary, because it can and may or may not surprise you. But also, like a lot of things in these crates are magic. Sometimes you just roll with it. If it doesn't matter to the work you're doing, you got to pick and choose your battles on the things you actually spend time learning. So in order of difficulty, the kinds of call patterns you should think about. So imagine this is Python code calling Rust code. Calling a Rust function that takes no arguments. Simple. Calling a Rust function that takes arguments, it's a little annoying. Like maybe you have to do a conversion, you have to kind of worry about type safety a little, but it's not too hard. Awaiting a function, that's where you get back into like complex questions about like signal handlers and block on, and oh god, now I have to think about how event loops actually work, and why am I learning about event loops? All I want to do is call a function. If you want to give callbacks, your life gets painful. And if you want to do streaming across that boundary, now you have to start really doing some shenanigans. And I'm happy to talk about it, but I'm gonna avoid that until questions. And then here's the laundry list. Cross-compiling still sucks in 2025. We have managed to solve propagating type annotations, but cross-compiling is still very painful, right? Like I showed you this slide of like fix Windows thing, add more targets, right? Like this is still really hard, especially when you're bridging languages, because not only are you building Rust, you may or may not be building underlying C libraries for the thing that you're building in Rust, and you're building into Python, Node, or Ruby. TypeScript, the ecosystems are smaller, right? Like of the set of Rust users, there are fewer people who write Python code in Rust. There are fewer people who write Node code in Rust. There are even fewer people who write Ruby code in Rust. Documentation is just less abundant. Bugs will require going 3 or 4 levels deep. This is a bug I found my way to July of last year, because like things broke in the build ecosystem, because CentOS 7, which is like, I don't know, 20 years old or something, like went end of life, and then our cross-compile toolchain broke. Reasons. TypeScript users still get confused about server versus client, because there are frameworks back that bridge this gap and do magic under the hood to move, like split out code in a single TypeScript application between servers and clients. And if you have a library that only works on servers and not in browsers, things will just magically break, and then your users will ask you questions about like, hey, how do I make your thing work? And then you have to explain to them, you kind of have to add magic strings in certain places. TLS semantics are their own balls of hair. Language versions, you have to start asking questions about like, how far back do you support Python? Even though 3 is end of life, we still have users on it. Max ship with Ruby 2.6, which has been end of life for 3+ years now. And then crate versions, you now have to coordinate your Rust crate version with your Python package version, your npm package version, and your Ruby gems package version. We took the lazy way out of this. We just said we're going to pin them all to the same version, which means that if we want to patch fix one of them, we have to bump versions in all of them, but it works for us. And if you want to see the non-demo version, that is our repo. There is a lot of code in there. Please do give us a star. This is the shameless plug. We are very close to 3,000 and we're growing a community. So yeah, just take a look if there are if you want to see some wild, scary things. Questions or no time? Cool. Yeah.
Add a little bit more, but maybe the promptly is